With Micronics Micron SLS 3D printer, SLS 3D printing has been becoming the new cool thing at the moment, especially at a price tag which is far below of any of their competitors. At Open Source this year, I finally had the chance to see this machine in action and talk to Luke and Henry about SLS in general and what the unique selling point of their machine is. I'll share my thoughts on the state of their printer. I ask the serious questions, what they still need to do after the Kickstarter to get their machine production ready, and ask some of the more unserious questions, for example, if you can put metal powder on their machine. Let's find out more. Guten Tag everybody, I'm Stefan and welcome to CNC Kitchen. This video is sponsored by Squarespace. Create the website you've always wanted or finally replace the old one that you've always hated. Go to squarespace.com/cnckitchen and give it a free trial. So Luke perfectly summarized why they started working on their machine 3 years ago.
You can design anything you want, but you're limited by the tools you have to make those things. So we thought, well, what if we made a tool that could make anything you can design? And SLS is about as close as you can get to that reality. We're Micronics, and we're building the world's first desktop SLS 3D printer. SLS, or Selective Laser Sintering, is a 3D printing technology that uses a powder rather than a filament or a resin, and it allows you to print your parts without any support structures. So this enables you to print super complex things like these compliant mechanisms and print-in-place assemblies.
SLS 3D printing has been around for ages, but it only got accessible recently because 10 years ago a patent finally ran out. Quite similar to the RepRap movement, this finally paved the road for more competition on the market. EOS used to be the most popular manufacturer of SLS machines over the last decades, but their machines start way above $100,000. With the fall of the patent, new competitors entered the market, and probably the most successful and most known is Formlabs with their Fuse 1, which initially cost around $20,000 and now with their latest revision sells for around $30,000. Micronics SLS 3D printer tries to disrupt the market with a price of only 15% of that, which could open the technology also to enthusiasts and small businesses. I said targeted retail price because their machine currently still is on Kickstarter. I'll share my thoughts on this in a bit, why I think this Kickstarter is different to many other Kickstarters recently. But how does selective laser sintering work in detail?
SLS works by spreading a thin layer of powder over a build area, and then we trace the cross-section of the part with a high-powered laser. Anywhere that the laser hits, the powder is melted and fused together, and anywhere that it doesn't hit remains a free powder. And so we repeat this process to build your part layer by layer. At the end, you can separate the unfused powder from your fused parts.
If you're not familiar with the process, it sounds a bit similar to resin 3D printing, but instead of curing a resin with UV light, you use a laser to fuse powder particles together. Yet, there is especially one big difference.
Our biggest advantage is that we can print without the need for support structures. So this allows you to nest your parts in 3 dimensions. So you can see with our build volume here, you can nest parts on top of each other and fill the entire volume without the need to worry about support structures.
There's no need for supports and you can directly print in thin air, or rather here in the powder bed. So finally, complexity is really free. But the loose powder itself wouldn't be self-supporting, and Luke initially didn't tell you the whole story. In SLS 3D printing, you preheat the whole chamber right below the melting point of the material. That partly sinters the material together, and that kind of creates a very loose support around the parts. So how are they doing this?
So in our heat up, what we do is we bring the build plate up to temperature along with the walls, and then we lay some powder at the beginning and heat that up to just below the melting temperature.
So if you look through the window during printing, you see this pulsing light, which is the heater. But what are they using here?
Halogen bulbs, and they dump a lot of heat and a lot of light onto the surface, and we've done a lot of work to make sure that's very uniform. For nylon, we print, we get the surface temperature up to about 180 C, and then we use the laser just to kick the powder over the threshold to turn it from solid to melted.
And this is one of the secret sauces here. If you don't heat up enough, your parts will curl and will interfere with the recoater. If you heat too much, your powder bed basically sinters together, trapping the parts, making them impossible to remove from the powder cake in the end. And this is the reason why they're getting away with a 5-watt laser. The powder bed is already preheated right below the melting point of the material and just needs this final kick to basically melt it. Yet, before we talk about why Micronics nylon powder is great, let's talk about why a great product is worth nothing if you don't have a professional website where people can find you, you can present your product in the right light, and finally give them the opportunity to buy it. This is where today's video sponsor Squarespace comes in. Squarespace is the best place to create a beautiful web presence in one of the easiest ways possible. You can either choose one of their beautiful templates and customize them to your needs, or try out their new Blueprint AI, which will generate a custom template for you with just 5 simple content and design questions. Blueprint AI will also automatically fill your website with custom content generated according to your prompt. Easily adjust the result to your needs and you're ready to launch in no time. Add a shop to sell your digital or physical products, or make a business out of your side hustle by selling courses, or add a members only area for your fans. I've been using Squarespace myself for my own website for several years now and can truly say that it's super easy to create your first website without any programming or design skills and then maintain it over the years and always adjust it to your needs. You can try it out totally for free if you go to squarespace.com/cnckitchen, and if you use code cnckitchen on checkout, you'll get 10% off your first purchase. Squarespace is a great solution for everyone, regardless if you want to make your own personal website, make a portfolio to showcase your work, or if you are a designer who wants to sell your creations. So create the website you've always wanted or replace your old one that you've always hated. Go to squarespace.com/cnckitchen for a free trial and 10% off your first purchase if you use code cnckitchen on checkout. So let's get back to Micronics Machine and what the downside of this blue laser is.
Since we're using a blue laser, the material needs to be able to absorb the blue light, which is why all of our parts are a dark material.
And this is something we can see on all of the affordable SLS 3D printers that use a diode laser. White powder would simply not absorb as much of the laser power to melt it. And if you take a look at EOS machines, for example, that use a white powder, they use a CO2 laser, which has a 20 times longer wavelength. This is exactly the same absorption problem that you can also see on laser cutters. So whereas you can easily cut a clear sheet of acrylic on a CO2 laser, it simply just wouldn't work on the inexpensive blue diode laser cutters. Yet that doesn't limit the material choice if you are able to source a dark powder.
Currently, we support nylon 12, which is our best all-around material. We also support TPU, which is more of a flexible rubber material. There's also glass-filled versions of the nylon and carbon fiber-filled versions of the nylon.
And if you want to use a material that is currently not supported, they give you all of the options to tune in the material yourself.
So we say we're an open material platform, and we expose all of the slicing settings to you so that you're able to tune and optimize for your own material.
Working with a powder can be a bit messy. And if you want to switch from one material to another using the same build chamber, this can be pretty involved, yet they have a solution for that.
So our build chambers are modular and you can fill them with different materials. So this allows you to change materials practically instantly. You can get separate build chambers or additional build chambers and keep materials in those build chambers, and so you can swap between them instantly. So one for a nylon and maybe another for a TPU.
The design freedom of SLS 3D printing and the self-supporting nature of the powder is great, but it also comes with a problem not many really talk about.
So there's a bit of degradation just from the thermal cycling of the material, and there is also some particles will fuse together.
So this means that you can't indefinitely reuse your powder. You always need to mix in a minimal amount of new powder in order to reduce the degradation effect.
We recommend a refresh rate of 30%, so that's 70% used and 30% new powder. You certainly can use more used powder. We've tested as low as 10% and it prints just fine. What you're compromising is the surface finish and the brittleness of the parts.
This means that it's a good idea to pack the building volume as closely as possible, because that means that you reduce the amount of free powder that will slowly deteriorate. Yet, how much is the powder in the first place?
So for PA12, the filament price is around $80 per kilogram. Our powder is around $88 per kilogram.
SLS 3D printing is especially useful for functional parts, yet how strong are parts printed with this method?
SLS is great because it does provide an isotropic material property. So that allows us to post-machine parts really easily. So this part, for instance, we added this hole after the fact and we just took a 20mm drill and punched right through it. No worries about delamination of layers or extrusion splitting.
This again goes back to Luke's initial quote.
You can design anything you want, but you're limited by the tools you have to make those things. So we thought, well, what if we made a tool that could make anything you can design? And SLS is about as close as you can get to that reality.
Isotropic properties means that your parts has similar strength regardless of the printing orientation, which gives you a tremendous amount of design freedom. But it's not only the strength of the part that it's nice. I've seen some really detailed prints at their booth. But what's the resolution of their machine?
So our step accuracy is under 5 microns, but the resolution or fineness of detail that you can resolve with our printer is limited by the spot size. So that's 0.25 millimeters.
Spot size means the diameter of the laser focus. 0.25 millimeters is not as high of a resolution as you would, for example, get with resin printing, but it is kind of equal to printing on an FDM 3D printer with a 0.2 millimeter nozzle, which gives you a tremendous amount of details, to be honest. I was curious about what layer height they're usually printing at.
We're printing these at 0.11 millimeters. You can vary the layer height, but we found that 0.11 is very good.
Yet before you can use or examine your parts, you need to get them out of the machine and also the powder cake. How's the process for that?
Post-processing, after you're done printing, you lift the powder cake from the build chamber with our scoop tools, and then you place them in a sifting bin. And this sifting bin has a sieve mesh in it that will let the powder be reclaimed and fall through, and your parts will remain on top. Now, we also highly recommend using a media blaster with glass beads. Not only does this give you the good surface finish of these parts, but it's a huge time saver.
So even though you don't need to remove supports from your parts, the post-processing step is still pretty involved. Their sieve bucket only removes the bulk of the powder, and you still need to use a brush or better blast your parts with glass beads to get a perfect surface finish. The parts are of course printed at 100% infill, which makes them almost fully dense. Yet if you need full gas tightness or a special surface finish, you need to further process them, and there are several ways to do that.
One that's really nice, gives this beautiful surface finish, is vapor smoothing. So we've sent these to a different company that vapor smooths for us, and that melts the surface of the parts and really seals it in. Some other processes, you could shot peen or tumble. You could also, what we've done here is spray paint these, so 1 coat of primer, 1 coat of spray paint.
So we are at the point where I need to voice some of my concerns, and to some this might sound really overcautious. I'm not 100% comfortable recommending SLS 3D printing to all consumers, because it can be a pretty messy process. This is primarily the plastics powder, which isn't only microplastics in its purest form, but if you don't use proper PPE, it can also pose a severe health risk. And this is not only when handling the machine, but also the powder and the parts itself. So what is Micronics doing to mitigate that risk?
So nylon powder is non-toxic, but we do have a lot of systems in place to mitigate the dust that's spread. So inside the printer, we have a carbon HEPA filter that filters out any particles or dust generated in the printing process. In post-processing, we have a fume or dust extractor that we've developed to create a draft to suck up any dust that's generated. And on top of that, we do recommend that all users wear an N95 or better mask when they're extracting the parts or working with the powder.
So an SLS 3D printer is nothing for your bedroom and your living room. And you should make sure to wear PPE all of the time, have a dedicated space for it, and also a vacuum cleaner nearby. And even though the pure nylon powder might not be a health risk, I don't even want to start thinking about the glass fiber or carbon fiber filled powder. People are lazy, and I just want to highlight that SLS 3D printing can be dangerous and you need the proper space for it. Yet also resin printing and even filament-based 3D printing are not healthy, but I want to make sure that you keep that in your mind when making a decision. I think you now understand how SLS works and what it can do, but I wanted to know what Micronics machines make so unique from their competitors.
I think we've finally shrunk the footprint and made the printer accessible enough to actually break into like a prosumer or enthusiast marketplace.
There are and have been other SLS 3D printers on the market, like the ones from Sintering and Sintratech. But why does Micronics think their machine is better?
So we've designed this machine from the ground up, and we control everything from our laser system and control modules to make it really accessible.
And what was the most challenging part when engineering the Micron?
Developing the laser control system has been a big challenge, but we're really happy with where we're at with the accuracy. We started by trying to use off-the-shelf parts for our laser system, but they just weren't cutting it with the accuracy we're getting out of those systems.
Hardware isn't everything, so they also made their own slicer using Unreal Engine 5 for best performance with like really complex prints, but it also has a really interesting feature.
So the slicer, it's really different from FDM slicing or for resin slicing, where you don't have to worry as much about the orientation. Since the parts can be printed without any support structures to print or nest multiple parts, we just use a physics simulation to pack the parts automatically. For larger parts, you're welcome. We also have controls to manually nest things, but for parts of similar size, it's really convenient just to throw them, like literally, and throw them into the build volume and have them pack themselves.
At the time of making this video, the Kickstarter was still very successfully running, but not everything went smooth with the first beta units. So what are they going to do once the Kickstarter ends?
So we're giving ourselves 8 to 12 months before we start delivering our Kickstarter pledges. In that time, we're going to do one more revision just to work out all the feedback, incorporate the feedback we've gotten from creators that we've beta tested our units. And so then after that, we'll start a final production run. With the iteration we'll make is we'll do one more round of beta testing as well.
And what are the primary things they will be working on?
The mechanical reliability is the biggest challenge we're working on. Things like our laser system has been flawless so far.
And here comes my second concern, and this is not about the technology, but the project itself. Micronics did an amazing job putting this machine together, shrinking it down and trying to make it affordable for enthusiasts and small businesses. And I could see with my own eyes that the machine is working and produces some really nice looking parts. Yet building 1, 10 or even 50 machines is different to making the machine ready for like small scale mass production, and similarly important, making sure that the machine can be shipped all around the world without getting damaged when the courier throws it down the stairs. So I think they still have a ton of work to do considering design for manufacturing and shipping, and this isn't a small task. The Kickstarter money will and needs to be used to finish the engineering of the product, but also to build the machines that people pledged for. I really hope this is working out for them because they already made a great product, but they still have a pile of work ahead of them. Honestly, this project uses Kickstarter as it once was intended for. Funding cool projects and not just using it as a pre-order and marketing platform. But if you already have or are thinking about investing in their Kickstarter, you also need to consider the risks involved. If they're not able to figure out all of the kinks of their machine and make it production ready, you might never see your money again. They are super smart guys, but there is a non-zero risk that this is not going to work out because SLS is not simple. Just think about Formlabs Fuse 1, which took 3.5 years from the first introduction of the machine to shipping the first units. This wouldn't be the first 3D printing Kickstarter that failed, even though I really hope it doesn't. So if you have the money to spare, know the risks involved and want to get into SLS 3D printing, Micronics project is worth supporting. They got the technology, but still need to figure a couple of things out. So I'd like to know your thoughts on Micronics SLS machine. Do you believe in it? Simply you want to have a desktop SLS machine, or do you have concerns of your own? Leave a comment below. And as a final question, I ask something many of you maybe also had in your head. Can you put metal on a Micronics SLS machine?
Do not put metal in this machine. Metal is much more involved where the handling of the powder, it's extremely toxic and you can start metal fires. Yeah. So we do not recommend using metal in this machine. The laser power is order of magnitudes too low for metal.
So for now, this is not going to be an affordable powder metal 3D printer. I hope you enjoyed this deep dive into SLS 3D printing and my thoughts on the project. Thanks for watching, everyone. If you want to support my work, consider becoming a patron or a YouTube member, check out our online store and take a look at these other videos right here. Thanks for watching, auf Wiedersehen and goodbye!